This is Darrell with Cisco Training. Today we're going to talk about how to filter route advertisements with RIP version 1. This is the network we're working with today. We are all of our subnets are /24s. We have 6 subnets. They're all in the 172.16/0.0/6. I'm sorry, 172.16.0.0/16 classful network block. So we don't have any auto summarization problems. We don't have any discontiguous classful nets problems. We don't have any variable subnet mask problems. One problem we do have, however, is our clock rates on our serial interfaces. We're going to vary them a little bit. On 2 of our serial links, we're going to set our clock rate to 1 million. On the 3rd serial link, it's going to be the clock rate of 64,000 that we've been working with. What that basically means is that this serial link and this serial link are fast. They're each 1 megabit serial links. This serial link is only 64K. So in terms of a bandwidth perspective, we have about 15 times more bandwidth on these serial links than on this one. But the problem is, in RIP version 1, our metric is hop count. We don't care how fast the link is. It could be 10 gigabit for all we care, but a hop is a hop. And 1 hop is preferred to 2 hops in RIP. So today we're going to look at a couple different ways to use filter lists to, we're going to use prefix lists and distribute lists and offset lists to change the metrics. Here is our top router. I've erased the config. Let's do our basic configuration. IP address 172.16.1.1. By now we should be getting pretty good at this. IP address 172.16.2.1, 255, 255, 255.0. This is DTE, so I don't need a clock rate. No shut. Int serial 1. IP address 172.16.6.1, 255.255.255.0. No shut. This is a clock rate, clock space rate 64,000, because this is our slow link. No shut. Let's configure our routing protocol. Router RIP version 1, network 172.16.0.0, and I'm also going to do something else. No IP domain dash lookup, because we're going to be doing some trace routes, and I don't want the trace routes doing DNS lookups because those are going to fail. Oh, hostname top. There we are. Now let's move to the middle router. Hostname middle, no IP domain dash lookup. I don't know why the dashes don't show up here, but they don't. At least not with this font. But I typed it. Int LO0, IP address 172.16.3.1, 255.255.255.0. Int serial 0, IP address 172.16.4.1, 255.255.255.0. No shut. That's DTE. Int serial 1, IP address 172.16.2.2, 255.255.255.0. That is a DCE interface, so I need to set my clock rate. I will try 1 million. No shut. Router RIP version 1, network 172.16.0.0, and let's test our interface. Ping 172.16.2.1. Ping is successful. That concludes the middle router. Moving to the bottom router. I hope you're all getting routers, scrounging routers, and following along. It'll be a lot more helpful. T, hostname bottom, int LO0, IP address 172.16.5.1, 255.255.255.0. no shut, int serial 0, IP address 172.16.6.2, 255, 255, 255.0, no shut, that's DTE, so I don't need a clock rate, int serial 1, IP address 172.16.4.2, 285.285.285.0, clock, space, rate, 1 million, no shut, router RIP, version 1, network 172.16.0.0, exit. Now I forgot something. I forgot to do no IP domain lookup. No IP domain dash lookup. When you're configuring routers in production, you want to have a standard configuration or a checklist so you follow, so you don't forget whatever your standard configuration is. It's okay for your standard config to not be perfect the first time around, but when you find errors in it, you want to go and correct it, so that way the next router you deploy is deployed correctly. So let's test ping 172.16.6.1, success. Ping 172.16.4.1, success. Show IP route. We have 6 routes in our routing table. Our 3 connected /24s, and we have 3 routes we've learned via RIP. 172.16.1.0/24. We go out our serial 0 interface. Let me see if I can adjust the window just a little bit so it doesn't scroll. There. Nope, not quite enough room. Okay. So 172.16.1.0 goes out our serial 0 interface to the top router. And that's bad because that's a slow link. That clock rate is 64,000 on that link. That we have 15 times more bandwidth going the other way, which is the problem we want to solve. And then 172.16.2.0 goes in both directions. Again, that's bad because one of the ways is faster than the other way. And then 172.16.3.0 goes out the serial 1 link. Let's try an extended ping. Ping protocol IP target address 172.16.1.1. See, this is where we typed ping without saying what IP address we were pinging. Repeat count is 5 by default, so I just hit return. Datagram size, let's set our datagram size to 1400. Timeout in seconds is 1. Default is 2 seconds, but you know, if you're sending 5 pings and it's not getting there and you have to wait 2 seconds each time, it takes a while. So I just type 1 out of habit. Extended commands, this is where we would specify what source IP we would be using. I'm not gonna answer yes at this point, so I hit return and it does no. Sweep range of sizes, that's where it's asking us if we want to, you know, do we want to send 5 pings and have them be size 200, 400, 600, 800. We'll go no for now. And there you can see that our speed was a lot slower than our normal pings, which are usually small. Our speed was 356 milliseconds for each ping. And that's going through the slow clock rate interface. Let's try the other way. Ping IP, target IP 172.16.3.1, repeat count 5, datagram size 1400, time in seconds 1, extended commands, no. Sweep range, no. And here it's 24 milliseconds. So there you can see that pinging through the clock rate 64,000 serial link is a lot slower than pinging through the clock rate 1 million. And it's particularly, there's a big difference when you're dealing with large size packets, size 1400 packets. So again, that's just more evidence that we don't want to route stuff through the through that slow link. Okay, so let's see what we can do about that slow link. We are on the bottom router, and let's start with the distribute list. Let's say, well, actually, I'm going to go to the top router because we've been thinking about how to get to the top router. So here we are. So conf t, let's put in an access list which matches, well, here, show IP route 172.16.5.1. And we get in through serial 1. That route is coming in through serial 1, which is our link on this, our slow link. So let's create an access list which matches that. So this is something new. Access-list 1. Standard access lists are numbered from 1 to 99. Access-list 1. I hit question mark, and it has deny and it has permit and remarks. So let's type in remark. Prevent slowness. This is a comment, and it's good to put this in your config. Access-list 1 deny 172.16.5.0 0.0.0.0. We are denying route advertisements which start with 172.16.5.0 for the whole /24. Or rather any, and then, but you see the thing is access lists have an implicit deny at the end. If I just ended the configuration of the access list here, then everything would be denied by the access list. So access-list 1 permit any end. So now we have got our access list. I do show access-list 1, and it denies this, and it permits the rest. It didn't show the remark, which is disturbing. Show run type include access-lists. Router thinks about it for a while because this is an old slow router, but you can see in the running config it has the comment there. Now we haven't done anything with this access list. We've configured it. It will deny this IP address, or it will deny a route advertisement where the route is 172.16.5.0. So let's router rip distribute-list question mark, and then it can have the access list number or access list name. Distribute-list 1 in question mark, and then I got a choice of interfaces, serial 1 end. So now I've configured my distribute list so that that route will be denied when it comes in. showIP route. Now something else in the showIP route is the age of the route. This route was last received or updated 19 seconds ago, the 172.16.5.0 via serial 1, whereas the 172.16.4.0, the one that came in serial 1, is also 19 seconds old. Now we should be receiving that advertisement every 30 seconds. So let's hit showIP route again. And here you can see the effect of our distribute list. The 172.16.4.0 does not match the distribute list. Well, the distribute list has a permit any at the end. So this is permitted by the access list. So we received that route advertisement again, so that route is only 22 seconds old. However, the 172.16.5.0 route is now 48 seconds old. But we're supposed to receive RIP advertisements every 30 seconds. So, as a result, now we do it again. Now that route advertisement is 1 minute 26 old. How long is this going to go on? We applied the distribute list, and we still have that route. Let's look at showIP proto RIP. showIP protocols RIP. Okay, it doesn't like that. showIP proto. It will tell us all of our protocols, our IP routing protocols, of which the only one we're running is RIP. So a route is invalid after 180 seconds. So even though we applied the distribute list, we successfully denied that route coming in. It will take 3 minutes. The route will have to be 3 minutes old before we will before we will get rid of the route, remove the route from our routing table. So you can see once again that RIP is a slowly converging routing protocol. And you know, the other problem we've done here is what we've done is we've taken this route, and if we're just denying it inbound. You know, if we didn't want to receive any routes on that path, we could have just shut down the path. this is not a very good way to reroute around a slow link. Because if our fast link goes down due to like a circuit failure, we'd want to use this link. But our distribute list is still going to be denying the route. So in effect, we've turned off our redundancy. We've sort of messed up here. So let's try something else. Show conf t router rip no distribute list dash list 1 in serial 1. So we've removed that link, show IP route. And now we've received that route 1 second ago on serial 1. Now, I don't know whether that was a coincidence or not. It might have been a coincidence that we received it right then, or it might have been when we removed the distribute list, we sent a RIP request packet out. So let's find out. Debug IP rip. Conf t router rip distribute dash list 1 in serial 1. So I've applied a distribute list, and it said sending triggered update. And then it didn't actually do anything. Well, maybe it didn't do anything because the distribute list was, maybe it didn't do anything because the distribute list was inbound. If that had been, but you can see that RIP here is trying to be smart. When we apply a distribute list, it sends a triggered update. Now let's debug IP rip no distribute dash list 1 in conf t router rip no distribute dash list 1 in. So now we sent a trigger update when our distribute list changed, but we didn't actually send any updates. Again, maybe because it was an inbound. And we did not receive a, so no debug all. We did not send any RIP requests out. So when in RIP, when you're applying a distribute list or removing a distribute list, the router considers whether to send a triggered update and will send it if necessary. In this particular case, it was not necessary. Now, it's an inbound distribute list. It will not send a request. It's only sending updates under those circumstances. Okay, so how do we know what distribute lists are in place? Showrun. One way is showrun, which will show you the running configuration. The whole configuration for the router, and there you can see router RIP, distribute list 1 out serial 1, distribute list 1 in serial 1. Okay, fine. The other way is showIP proto. In showIP proto, it shows information about the routing protocols, and RIP is a routing protocol. Outgoing update filter list for all interfaces is not set. That's a distribute list which applies to all interfaces. However, we have set distribute lists for specific serial interfaces. So outgoing serial 1 is filtered by 1. Incoming serial 1 is filtered by 1 because I've got my distribute list applied in both directions right now. Now let's clean that up. Conf t router RIP no distribute dash list 1 in serial 1 no distribute dash list 1 out serial 1 and showIP proto. And there you can see that it's gone. The distribute lists are the filter lists are all gone. Okay. So again, distribute lists don't make much sense here. What we really want to do is we want to increase the cost of this link so that it might be count as like 3 hops. So that way here to here is preferred over our fast links. So let's think of a way to do that. Conf t access dash list 2 permit any. Conf t router RIP. Let's do offsetlist offset dash list to out serial 1 offset dash list to out offset list to out, and let's normally we send it with a hop count of 2. Let's set let's set it with a hop count of 3, which means we want to add 2. Serial 0, and that will make it so that any routes that we send out will have 2 extra hops on it. Offset dash list to in, and our offset, let's make the offset 3 for inbound. And you know we're supposed to be doing this on serial 1. I made a mistake, so no offset dash list to out to serial 0, offset dash list to out to serial 1, end. Show run. That was sort of confusing because I typed the wrong command. See how easy that is to do? They say 1/3 of network outages are caused by human error, and that was a human error. So router rip offset list to in 3 serial 1, offset list to out to serial 1. Show IP route. So now, okay, so this is interesting. Before, we had 2 routes to the 172.16.4.0 network. One of them was via serial 0, and one of them was via serial 1. Now what we've done is we've created an offset list where inbound route advertisements are given additional hops. So now we have 2 ways to get to 172.16.4.0. One is 1 hop via serial 0, and the other one is 2 hops via serial 1. Well, 1 hop is better than 2 hops in RIP, so only one next hop is being inserted for this subnet. Meanwhile, the 172.16.5.0, we get that via, we still prefer serial 0. Yeah, we prefer serial 0, and it's 2 hops away. Let's show IP RIP database. So show IP RIP database 172.16.4.0/24. We got 1 hop via serial 0. 172.16.5.0/24. We got 2 hops via this. That didn't show me all the information I wanted. So IP RIP database 172.16.4.0. 255.255.255.0. It's only showing me the one path. I want to make sure I'm receiving all those routes. So debug IP RIP. I would have hoped to have seen the alternative paths. And now we'll wait a few seconds. Let's see the receiver out. Okay, so we sent stuff. Okay, so let's look at what we sent. Show IP proto. So scrolling back, outgoing routes in serial 1 will have 2 added to the metric if they match list 2, and list 2 is permit IP any. So list 2 matches everything. Incoming routes in serial 1 will have 3 added to the metric if it matches list 2 again. So outgoing routes have 2 added to the metric. So let's look at our advertisement. So here's what we sent out, serial 1. Normally, we are directly attached to 172.16.1.0. Normally, we would send it with a metric of 1. However, we're adding 2 to the metric, so we're sending it with a metric of 3. 172.16.3.0 is 1 hop away from us. So it's already one hop when it gets to us. Normally we would add another hop, so we'd send it with a metric of 2. However, we're adding 2 thanks to our offset list, so we send it with a metric of 4. Okay, so that's it for our outbound. Now our inbound, we add 3. So let's look at what we received. Here's a version 1 update we received on serial 1. And the bottom router is directly attached to 172.16.4.0 and 172.16.5.0. However, our inbound offset list adds 3 hops. Now it sent it to us with 1 hop, we add 3 hops, so now it's 4 hops away that way. Okay? So that's it for offset lists. Let's look at our config one more time. So our access list 2 is permit any, and then our router RIP statement, we have offset list 2 in 2, offset list 2, so it's access list number 2. Inbound, we add 3 hops and it's serial 1. And offset list, access list number 2, out, add 2 hops on serial 1. So that's it for offset lists. So we have done distribute lists and offset lists. And if we wanted with the offset list, we could make the offset list for a specific route. In fact, let's go ahead and do that. So conf t router rip offset dash list 1 in serial 1. I'm sorry, 1 in 2. So actually, let's add 6 hops in serial 1. End. So what's interesting here is we already had an offset list applied to the interface. So, but now we've overridden that previous offset list. You can only have one offset list in a particular direction on a particular interface. So when I configured the new offset list, I blew the old one away. It's gone. If I don't have a backup config of this router and I don't have a I can't scroll back in my buffer, then I will have no idea what the offset list I just eliminated. So it's very important to back up your router configs from time to time if the box is production. Okay, so we got our offset list 1 in serial 1. So let's look at our debug IP RIP. And wait for a received item on serial 1. There it is, no debug all. So I show access dash list 1. Access list 1 denies or does not match 172.16.5.0. So what that means is this subnet is not offset. And as you can see here, we get that route in 1 hop. It was not offset. All the other routes are permitted, so all the other routes are offset. So this is almost the so yeah, before when we did the distribute list, we denied this route and did not accept the route. Now when we're doing the offset list, when we deny in the offset list, it's saying the offset list has no effect. In this one, when we permit with the offset list, permit anything else, then the offset list has an effect. So we had an effect on 4 routes, and the only route we did not have an effect on was the one that was denied in our access list. Okay, that concludes today's session on distribute lists and offset lists in RIP version 1.